So the sum and the difference of fifth powers you would have, so when you have a minus in the middle, you have a minus b. You start off with a minus b when you have a minus in the middle, and then you get a to the fourth plus a to the third b. So basically, let me write it down and explain what happened. So a to b2 plus a b3 plus b4. So let me explain what is happening right here now. So you're basically subtracting 1 from the a power as you go down. So as you realize you have a to the fourth, then a to the third, a to the second, a to the first, and then no a, that's a to the 0th power, right? So you're doing the same thing for the b, but except that you are increasing the powers. So right here we have b to the 0th power, then b to the first, b to the second, and b to the third. So as you're adding to 1, you're subtracting from 1. But what you need to remember, that's the easy part, what you need to remember is the signs that are supposed to be there. So when we're doing with a to the 5th minus b to the 5th, you have to start off with a negative right here, and then all of the other ones are positive. Let me just do a to the 5th plus b to the 5th. So just go over this, type in sum and difference of odd powers on Google, and you'll find it. I'll probably insert the picture. So if you're doing a to the 5th power plus b to the 5th power, you start off with a plus b, right? And then you're going to say a to the 4th minus, see that? Minus a to the 3rd power b plus a to the 2nd power b2 minus a b3 plus b4. So for the addition one, you're alternating. You're going plus, minus, plus, minus, plus. You understand? But for this one, it's just the one minus, and then every single thing else is a plus. Okay? Alright. 2, I'm going to jog your memory, factor theorem and remainder theorem. So for this one now, we're told that a remainder of 3 is obtained when 8x cubed plus 4x plus k is divided by x minus 1. So basically now, we're going to equate this x minus 1 to 0. So therefore, when x is equal to 1, so when x is equal to 1, there's a remainder of 3. Alright? So we have 8 open bracket 1 cubed plus 4 1 plus k is equal to 3. Now that is 8 plus 4 plus k is equal to 3. 12 plus k is equal to 3. K is equal to, 12 plus k is equal to 3. K is equal to negative 9. Root x plus 4 root 3x, right? And all of that is over 48. Now we're being asked to simplify it. So I'll say, alright, so I'll go on for this. What can I do? So the first thing I'm going to simplify is this denominator, because it's so big and just unnecessary, like, because this looks simplified to me. This isn't bad, and this is just there, which I know can be simplified. So what are the factors of 48? So to get 48, I can do 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8, right? So now, which one of these are a perfect square? So I know that 16 is a perfect square. Perfect square is like 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. So this is 4 times 4. So when you're doing thirds, you need to know your perfect square. So this is 3. So we're going to extract this one. So this is 3 times 4 squared. Right? So therefore, root 48 is equal to root 3 times root 16. This is equal to root 3 times 4. I'm just going to carry the 4 here. So that's 4 root 3. And I say, oh, it looks like the top, but you have this x. But don't worry. Don't worry. So we have 4 root 3. So now we have 4 root x plus 4. Okay, so root 3x is the same thing as root 3 and root x, right? So review your third rules. All over 4 root 3. So now you can simplify and have 4 root x is equal to 4 root x plus x, because this would cancel, and that would be equal to, so this is basically 1 root x, so that would be 5 root x. Okay, so for this question we're given some logs and we're basically being asked to simplify this. So before you look at this question, you need to know your laws and your logs, and if you know how it behaves when you're subtracting, when you're adding, when you multiply, power, just know all of the law of the log them. You understand? Because in an exam, you have a small amount of time, you're not supposed to think about the law, you're supposed to know the law out of your head. So first things first, we see 2 of these and we say, alright, they're being subtracted. So you know, when 2 logs are being subtracted and you want to combine them together, you would basically you'd basically be dividing. So therefore we'd have log 2. But before I get into that, this 3 on the outside, what's going to happen to it? Right, there's also another law, the log, that takes into consideration the power. So basically this 3 is now going to cube all of this, right? So big bracket, on top we're gonna have 2q cube, on the bottom we're gonna have 3q squared. Everybody understand? So the 2 come from here, so I'm going to square all of this. The 3 come from here, so you're going to square all of this. You're not going to take into account the negative because you're already dividing, right? And there's also a law that says log b is equal to 1. So therefore log 2 of 2 is equal to 1, right? So we're going to sort this one out first, and we're going to take into account this one. So we have log 2 open bracket, and that is 8q to the 3rd power over 9q squared plus log 2 of 2. So we say, alright, this is not in the this is not one of the options. So what do I do? So what we're going to do now is that we have two logs of the same basis being added, so that is now multiplication. So we're going to be multiplying this 2 by this. So I'm losing space over here, so I'm just going to write it on this side. So we have log 2, so there's 2 times 8, that would be 16. Oh, these, you have q to the 3rd power and q to the 2nd, so therefore they would simplify and this would just be 8q. So you have 16q over 9.